On September 5, 1977, a small spacecraft lifted off from Cape Canaveral, Voyager 1. It was designed to study Jupiter and Saturn, to photograph their moons, and to explore the giant planets' atmospheres. Few could have guessed that this machine, built with 1970s-era technology and memory smaller than a digital watch, would one day travel beyond the solar system itself. Voyager 1 was part of a twin mission, alongside Voyager 2, sent to follow a rare planetary alignment. Its job was simple: explore, record, and send its discoveries home. But the result was far more. It became a bridge between worlds, and the first human-made object to enter the space between the stars. Journey through the giants. Voyager 1 forever changed our understanding of the outer planets. At Jupiter, it captured swirling storms larger than Earth and watched volcanic plumes erupting from the moon Io, proof that our solar system was still alive with activity. At Saturn, it revealed the complexity of its shimmering rings and mysterious moons like Titan, where dense orange clouds may conceal seas of methane and ice. With every image transmitted across billions of kilometers, our picture of the solar system transformed, from distant points of light into dynamic worlds, each with its own chemistry, geology, and atmosphere. Originally built for a 5-year mission, Voyager 1 has now operated for nearly half a century, traveling over 15 billion miles from home. Its success redefined what humanity could accomplish with precision, patience, and imagination. Crossing the boundary in 2012, Voyager 1 reached a historic threshold, the heliopause. This invisible frontier marks the place where the Sun's solar wind weakens and the true interstellar medium begins. Crossing it meant that the spacecraft had officially left the solar system and entered the space between the stars. This boundary isn't fixed, it expands and contracts with the Sun's 11-year solar cycle. During periods of strong solar activity, the Sun's magnetic influence pushes outward. During quiet times, it retreats. Voyager 1's instruments revealed that the edge of our star's reach is a shifting, breathing frontier, shaped by forces from both inside and beyond. Even now, Voyager continues to transmit data about magnetic fields, plasma waves, and cosmic radiation. The faint pulses it sends, taking nearly 22 hours to reach Earth, give scientists an unprecedented view of how the galaxy interacts with our solar system. Strange signals from the deep. Recently, Voyager's instruments have detected unusual, structured plasma waves and repeating energy patterns, unlike the random noise typically seen in deep space. Some researchers believe these are the effects of complex interstellar plasma interactions or shifting magnetic turbulence. Others suggest more speculative possibilities, unknown cosmic processes, or even the faint signature of something artificial. Though these ideas remain unproven, they fuel debate across the scientific community. Voyager 1's readings challenge existing theories about cosmic radiation and raise profound questions about what truly fills the space between the stars. Some scientists have even proposed that advanced civilizations, if they exist, might use the interstellar plasma itself as a medium for communication. Whether natural or not, these signals remind us that the universe is far more complex and interconnected than we ever imagined. Survival against time. Voyager 1's power comes from radioisotope thermoelectric generators, small nuclear batteries that convert the heat of decaying plutonium into electricity. Each year, they grow weaker. To keep the spacecraft alive, NASA's engineers have slowly turned off non-essential systems, preserving only the most critical instruments. Voyager has endured freezing temperatures, relentless cosmic radiation, and the emptiness of interstellar space, and yet it still speaks to us. Its continued operation is not just a scientific triumph, but a symbol of human persistence. Even though it uses 50-year-old hardware and a computer weaker than a pocket calculator, Voyager continues to expand the boundaries of human knowledge. It has become both a tool of science and a testament to endurance. The golden record, a message for eternity. Bolted to Voyager's frame is something extraordinary, a gold-plated record, carrying the sounds, music, and images of Earth. It includes greetings in 55 languages, the laughter of a child, the sounds of rain, ocean waves, birds, and thunder. There is classical music, folk, the golden record, humanity's handshake with the cosmos. The golden record isn't a beacon for rescue. It isn't a cry for help in the dark. It's something much deeper, a declaration. It says, we were here. We learned. We dreamed. We reached outward. Carried aboard Voyager 1 and 2, this small golden disc holds the essence of our world. 115 images, greetings in 55 languages, the sounds of wind, thunder, laughter, even the cry of a newborn baby. It carries music from Bach to Chuck Berry, tribal songs from Africa, the heartbeat of humanity recorded in analog grooves. It's not meant to summon anyone. It's a time capsule, one that says to whoever might find it, be they alien or our own distant descendants, we were capable of wonder. We were capable of compassion. We wanted to connect, to share our story, and to leave something beautiful behind. When Voyager launched in 1977, no one knew if the record would ever be found. But that wasn't the point. The point was to say, even in a vast and silent universe we spoke. Echoes in the dark. Decades after launch, as Voyager 1 crossed the boundary of the solar system, its instruments began to hear something astonishing, the voice of interstellar space itself. Through its plasma wave detector, the spacecraft captured faint vibrations caused by charged particles drifting between the stars. When scientists converted those vibrations into sound, what emerged was haunting and ethereal, a cosmic symphony of slow, echoing tones. They called it the plasma hum. It wasn't silence. Space itself was singing. And within that song, scientists began to notice repeating pulses, subtle rhythms that didn't fit any known model. Were these patterns natural resonances of the galactic medium? Or something yet unseen, perhaps the fingerprint of an unknown process? The answers remain out there, waiting. Each packet of data that reaches Earth travels for over 22 hours at the speed of light, a postcard from the edge of eternity. Every whisper reminds us that even at 24 billion kilometers away, Voyager 1 is still exploring, still teaching us what it means to listen to the universe. Legacy and the pale blue dot. In 1990, as it prepared to leave the solar system, Voyager 1 turned its camera back for one last look, and captured an image that would change how humanity saw itself forever. The pale blue dot. From 6 billion kilometers away, Earth appeared as a mere speck, suspended in a shaft of sunlight. That faint pixel contained every ocean, every forest, every mountain and city, everyone who has ever lived, loved, fought, or dreamed. Astronomer Carl Sagan, who helped inspire the photo, said it best, "Look again at that dot. That's here. That's home. That's us." It reminded us that our divisions are illusions, that our planet is fragile and finite, and that against the backdrop of infinity, we are one. Voyager's legacy transcends science. It's philosophy in motion. It tells us that exploration is not about conquest or profit, it's about perspective. Projects like Breakthrough Starshot and interstellar probes of the future draw their inspiration from this tiny traveler. They continue its message: keep going. Keep learning. Keep listening. The endless journey. Someday, perhaps soon, Voyager 1's final signal will fade. Its power will drain, its instruments will fall silent, and its antenna will no longer whisper across the cosmic ocean. But even then, the spacecraft itself will endure. Drifting through interstellar space for millions, perhaps billions, of years. It will orbit the center of the Milky Way long after Earth's continents shift and our civilizations become dust. In that endless night, it will remain, a small metal relic of a species that once looked up and dared to wonder. Maybe one day, another intelligence will find it. They may touch the record, listen to our greetings, our music, our heartbeat, and wonder who we were. Or perhaps it will remain forever alone, gliding silently between the stars, a monument to curiosity, and to the human need to reach beyond what we can see. Conclusion. The voice that never fades. Voyager 1 is more than a spacecraft. It's a story, the story of us. It reminds us that distance cannot silence discovery, that time cannot erase curiosity. Even as its signal weakens, its purpose grows stronger. It continues to carry a message written not in words, but in courage, the courage of a small species from a small world that chose to explore the infinite. As it sails deeper into the cosmic sea, Voyager carries a light that may outlast the sun itself. A light that will continue to whisper through the void, saying, "We were here. We learned. We dreamed. We reached out. We tried to understand. And we never stopped listening."